Hey everyone, it's Wazesha Wednesday. I'm here on a Wednesday. It's not a sunny Wednesday. It's actually pretty dreary weather out there, but I'm excited to be back on Wazesha Wednesday. So I had a really good session last night. Last night I was talking about your value worth and how to increase your value worth. And I posted the link on Facebook for the session yesterday and for the session that I'm going to have tomorrow. So, PSA, if you want to increase your value worth and yeah, want to stop being average, please look at that calendar invite, register for the session, attend the session. I think there's going to be some really valuable information. But anyway, so this happened to me today. At work, having lunch, and some colleagues came up to me, people I know, don't know well, but I see them in the office all the time, and they're like, "Hey, so what do you do?" And I started my spiel. Well, I'm in technical infrastructure deployment engineering. So what we do is we get this, machine learning designs, infrastructure, and we deploy them in our data center so that people can use ML for the AI services or something like that, right? And they looked at me like, slow down, dude. What are you talking about? And I've said this often. I've said this a lot. The fact that you work in a tech company doesn't mean you're tech. I would say, I don't know, maybe 40% of the people in the company I work for at Google are not technical at all. But you walk around assuming because you work in a tech company, everyone's technical. But anyway, they're not. They weren't technical, and so I had to figure out how to break this down for them. And it's not the first time that I've been asked to do this. Sometimes you're having dinner with friends, lunch with friends, drinks with friends, and they ask you, "Hey, what do you do?" And you start explaining, and their eyes just glaze over. Sometimes out of boredom, sometimes they're just like, "Dude, just make it easy for me." Then I was at the gym the other day, and there's this mother who works out there. She was like, "Hey, I know you work for Google. I have all these pictures, and I just need to kind of figure out how to get them, in a place where I can view them." And I was like, "Yeah, just use the cloud." And she was like, "What does that even mean?" So I've been in a lot of situations where people ask, "What is the cloud? What is ML? What is AI? How does it even help my life?" and stuff like that. So thought, you know what, there's no better place to uh, explain this than on Facebook Live and on my Facebook Live. So if I end up embarrassing myself, everyone who knows me can say, that guy Kumbe is full of BS. Yeah. So anyway, so today I'm going to try and attempt to explain this. And um, yeah, I think what I'm going to do is I'm going to start by using this. Okay, so this right here is a computer, it's a laptop, right? Why do they call it a laptop? Because it can sit on your lap. How is it different from a traditional computer? Traditional computer, you had a desktop which would sit on the desk and was immobile. You couldn't move it because as soon as you unplugged it, the power went off. These started being produced because you can carry them anywhere. They store a lot of power in their battery, and so you don't need to stay in one place to use it. So most of us grew up without computers. Most of us graduated to a computer at a very late age. I'm here confessing myself over here, and and so now you have this, right? You have the mobile device. So think about the mobile device, the laptop, the desktop, as just computing uh, devices, so to speak, right? And so I'm going to use those to demonstrate what each of these things are. So I'm going to go through starting with a computing device, then I'll talk about cloud computing, then I'll talk about machine learning, then I'll talk about AI. So this is a computer. Why? Because it has a processor, it has memory, it has a way of receiving input from you, processing that input, and then giving you an output. So really that's what a computer does. You give it a set of instructions, it processes the instructions and it gives you an output. Sometimes the output is on on your screen, right? Like when you click Google Chrome and you put a search criteria, it processes that input and then displays it. So that typically is really what a computer does. And then you store things, right? Like you store information in files and folders and you retrieve them when you want to retrieve them. And then finally, it connects you to the internet. And so it is also some sort of networking device. So network, compute, storage. Those are the three things that the computer does for you. Network, compute, storage. Don't forget those. Okay. Now imagine if instead of having one computer which only had the power, one computing device, which only had the power of that computing device, what if you had the computing device of hundreds of thousands of computers? That means whatever you put in there could be processed so much faster, could be shared amongst all the computers and then given back to you. Wow. Yeah. Yeah. We used to have a very powerful computer called a server, which was, in essence, just a really powerful computing device because it has more power, more storage, can do all of that a lot faster than this device can, and a lot of more than this device can. So really the important thing to sort of capture here is that the more processing you require, the more storage you require, the more networking you require, will require a faster, bigger, more powerful machine. And that machine is called a server. Now, if you take many of those servers and you were to try and put them in your room, like in this office that I have here, imagine if I put all these computers in this room here. Imagine how much power I have, how much processing power I have, how much storage I can store a ton of things. I would have a supercomputer, especially if all those computers acted as one computer in this room. So let's say this room could hold, oh no, let's say 5,000 computers, right? All the power, that the processing power, I could ask any question. Computer one would use the power of computer two, three, four, five, six to answer the question for me. It's like asking a question from the smartest people in the world and they would respond real quick. So a data center is exactly that. A data center is where you have multiple machines, powerful machines, in one location. And what does a data center look like? A data center looks like, think about any big warehouse store, Costco, Walmart, Target. When you walk in, you see all these rows of shelves, and then there's produce or product on all of the shelves, right? So a data center is very similar to that. You have this humongous building, IKEA size, Costco size, Walmart size. You have rows, just like you have rows in those facilities. Instead of shelves, you have these things called racks. And a rack is really like a shelf. So imagine each of those shelves just has computers, 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 computers. So the idea is, instead of you trying to use this one device or you trying to cram 3,000 computers into your office, why don't you put 100,000 computers in this big building and make sure that the computers are put in such a way that they can talk to one another, they can use one another's resources, and can provide output to someone? That, my friends, is called a data center, and that is called the cloud. So if anyone ever asks you, what is the cloud? Don't look up in the sky. I want you to, in your head, think about a Walmart, a Target, IKEA, whatever. Is Uchumi still there? Uchumi, whatever it is, this big building that has all these shelves. And instead of looking at the bread and the eggs and the candy and the beer and whatever, think about computers being on all those shelves. That building is called a data center, and that is referred to as the cloud. So when we say cloud, we're just saying it's a collection of hyper powerful computing devices in a location, a building, where they can be connected to one another and act as a supercomputer. Now, why is that important for people like me, for people like you? Well, I'll, you don't have enough storage on your phone, you don't have enough storage on your computer, you don't have enough processing power on your phone, you don't have enough processing power on your computer to be able to do the things that you do so easily today. When you take pictures, like I think if I look at my phone, in fact, my phone just told me, you, Ichi, you take too many pictures. I have 23,000 pictures here, 23,000. I probably have another 50,000 or so in the cloud. So why is this important? It's important because my computer, my computing device, in this case my phone, is not able to hold as many pictures, as many photos as I am capable of taking. So whenever I take a photo, and this is an experiment you can do when you're trying to explain cloud computing. In fact, let me tell you how I did it. To this mother in the gym, I said, okay, every time you take a photo, okay, we can set your phone up to where it automatically sends the photo to the cloud. So what does that mean? You take a photo on your phone, the photo travels through your phone network to Google's network and ends up in a machine in one of Google's data centers. Remember, I told you the data center is the cloud and gets stored there. Why is that cool? Well, because if you put your phone away, you can go to your other computing device, this, you can open it up, you can go to your Google Photos and you can look at the photo that's now stored in the cloud. So you can have all these multiple devices that do not have to have the picture, but can access the picture because it's in the cloud. Now that's kind of scary. So my picture is out there in a data center, in a machine, in a building that looks like Walmart, IKEA, and Target. Yes, it is. But it's very protected. In fact, more protected than you are carrying this device where it can be stolen, it can break, it can just, some of these phones, they just die. And when it dies, it's gone. But if your information is in the cloud, you can retrieve it from anywhere. Let me tell you a story. So a long time ago, I started teaching, let's see, I think it was 2007. So that's what, 18 years ago, I started teaching. And back then, when I went for my classes to teach it was, networking classes, intro to computing, all these classes, I used to carry all these books and I used to put them in a brown briefcase. Like, imagine like a professor, I have my kabuti, tie, my brown briefcase, and I'm walking to class. And then I would open up, the books and, I would go to the board and I'd have a dry erase board, sometimes a chalkboard, and I would draw circuits and routers and switches and stuff like that, right? And then a few years later, I stopped carrying the books in the bag because I figured I can put all my material in slides, PowerPoint, etc., and save them on a jump drive. And I can take that jump drive and actually use it to teach my class. So I started using a jump drive to teach my class. Carried maybe a book just to, again, we have this attachment to paper. So I carried a book to show that, my attachment to paper, but really everything was in the jump drive. And I'll never forget one time I went to class and I'd forgotten my jump drive. And I remember calling Wawa and I'm like, oh, I forgot my jump drive. Go to the computer, go to this folder, then email me this. Okay, and she did. Emailed me, and then I was able to teach. Fast forward, my last few years when I've taught, I carry nothing. I walk into the classroom with nothing. Why? Because everything is in the cloud. Remember the description of the cloud. Cloud is a set of computers which are deployed. We'll talk about what deployed means, which are deployed in a data center. A data center is a building just like IKEA, Costco, Target, Walmart, where all the shelves where you'd expect produce in those grocery stores is actually shelves of computers, and all those computers are interconnected together to act like a supercomputer. So anything you upload to the cloud goes and it's shared amongst those computers. That way, even if one computer dies, another one has a copy of what you have. So it's very, very safe, very resilient, and you can access it from anywhere. So that, my friends, is cloud computing. It's not that thing in the sky. It's an actual physical building, and we have many of them. Literally, and when I say many, I mean not just one building. Like one data center could be one building, could be two buildings, could be 10 buildings, could be 15 buildings, it could be a campus. So these things are ginormous and they just have computers. In another Wazesha Wednesday, we'll talk about what it takes to build a data center when you talk about networking power, cooling, and all that, but not for today. So far so good. We know what a data center is, we know what cloud is. So what is ML? What is ML? ML is machine learning. Okay? So this machine is very powerful, but it could be more powerful. Imagine if this machine was more powerful than any machine you've ever had. And so, over the last, I would say, seven, maybe over the last 10 years or so, we have seen an increase in how powerful computers get. Before, there was sort of like moderate increase in speed. Could a data center still be hacked? Good question, Monga. I would say the short answer is very unlikely. And I'll tell you why. So, when you think about a data center, you have to think about maybe three elements of being hacked. There's the physical, meaning how can I get into a data center so that I can access someone's computer, right? And so, in the data centers that we have, it's probably 1 or 2% of the people all over Google who are allowed to enter the data center. It's extremely difficult. You have to go through all these access controls to be able to enter them. So physically, it's almost impossible. We have revolving doors, we have retinal scans, all that stuff to be able to get it. So that's one. Two is the whole notion of um, virtual access and how difficult it is to penetrate through all the virtual firewalls, all the virtual and logical controls that are in place. So, you being able to, let's say, sign in as Monga to be able to access Ichi's documents, impossible. Now, you could hack me if you pretend to be me. So, like anything, if you have my information, that can happen. But if you're trying to hack by being you, by introducing some sort of virus, by getting me to click on something so that you can access my information, I would argue in the cloud it's more difficult because we have that much more regulation to be able to stop those hacking attacks. And in fact, companies like ours and companies like other mama companies, we have hacking competitions to see can you hack into and get access to someone else's information. So that's the second thing. The third thing is the whole notion of encryption. Encryption means basically, I don't know if you remember when you were a kid and you would create this like codes and decode if you wanted to send a message to someone. So instead of saying I love you, you say I is maybe represented by the number 2, love is represented by the number 656. So you have a mechanism to translate this plain text into something that someone cannot read. That's called encryption. So encryption has become it. I'll come back to. It's interesting. It's become more complex, but yet we have more machines that can break it down. So even if you got access to the data, it would be encrypted, so you wouldn't be able to actually see it. So those are at least three things that could happen to protect your data. But I would say this: I trust my data in the cloud more than I trust it in my laptop, on my phone. My phone, my laptop can be stolen. The data in the data center is protected. I'll say this too. I remember people used to ask me about, um, security when it comes to cloud computing. And Monga, I know you've been here as long as I have. At one point in time, we used to go to the grocery store, write a check, put our address on a check, put our driver's license number on a check, and hand it to a cashier who handed it to their supervisor, who handed it to their manager. We had like 7 or 8 hands that handled that check with all that information that pertains to us. And yet we were okay with it. Cloud computing offers solutions that are much safer than that. Okay, so we know what cloud computing is, we know what data center is. I lose phones and drop them always. And that's why you need cloud computing because, look, I drop my phone, my information is not on the phone. My information is in the cloud. That means I can access it from anywhere as long as I have my username, my password, and someone allows me to use the computer, right? Okay, so let's go to machine learning. What is machine learning? Um, like I said, over the last 5 years, technology has really helped. I would say seven, let's say 7 years. There's been an acceleration in how fast the processors have become. And so what that means is we're able to compute a lot more, which means we're able to process things a lot more faster than we used to in the past. You have companies like Nvidia, you have Google, you have AMD, Intel, all these companies that produce processors, chips, that are now producing them in more power than we've ever seen before. And so now we suddenly have this machine that I'm talking about having a processor that's so powerful that it can process things so fast. Now, because of that, we've created these machine learning systems, which is really basically a very, very fast supercomputer. So this supercomputer that we call a machine learning machine is able to not only uh, perform fast, but you group these machines together and you have, remember I talked about supercomputer, you have hyper scaling computer, hyper scaling compute. That means they are capable of processing so many things instantly. And then not only do you create this machine learning, we call them pods, which are, hundreds of machine learning computers connected to one another acting as one, but you give them access to not just the information, remember the information in my computing device, you give them access to all the information all over the world. And what do they start doing? They start learning. They start analyzing. They start gaining insights. It's almost like you have your own personal, like, think about all the teachers that you really liked who taught you a lot of stuff. Imagine if you had access to all those teachers real time. You could ask a question to one teacher, not only get the response from that teacher, but have that teacher talk to all other teachers all over the world so they can consolidate all that information for you and then return the information to you in a way that you could learn. That's what machine learning does. Machine learning, again, simply put, is just this really powerful computers that when you put them together are able to communicate with one another, are able to learn from one another, gain insights from one another. And really, it's like having the entire set of libraries that you've always dreamed of right here in your fingertips. So that's what machine learning is. And so what machine learning has done is that it has revolutionized what's called AI. What is AI? AI stands for artificial intelligence. So artificial intelligence is just really the way I would describe it is just the service that you get because of these machines that are doing this machine learning thing. So think about it. All these machines are doing all this machine learning thing, and then someone up there is saying, "Oh, you know what? What if I ask it a question?" And the machine says, "Oh, you just want an answer to this question?" It processes it, it learns, it processes it, it responds to you. You say yes, you like it or don't like it. It takes that answer and learns from that answer And by the way, someone else is doing the same thing somewhere else. So these machines are just learning. It's like a 2 year old kid, a 3 year old kid just going around learning. Ask it a question, it responds. Ask it a question, it responds. Machine learning is the key to AI because now we are at a place where even though machines used to learn fast, we're at a place where machines are learning at a pace that we have never seen before. And because of the pace that we've never seen before, people are able to build services on top of them, these AI services, that then allow or utilize or leverage the power of these machines. So I hear people talk about ChatGPT. You'll hear people talk about Gemini, which is the Google product. And I'll be very honest with you. I'm probably using a tenth of a percent of what I could actually use these machines for, right? You hear machines as agents, you hear about Vertex, you hear about predictive, you hear about generative. And by the way, we'll have Stephen Kihumba is going to come on Wezesha to talk about AI and machine learning. I've already told him he's going to do it. But here's the thing: over the next 6 months, I'm going to commit to learn what the power of this AI is so that I can present it here on Wezesha Wednesday. But for those of you, Akinamonga, people like me, people who are in corporate, people who are entrepreneurs, using artificial intelligence, even using those little chat GPT or Gemini prompts is a game changer because whatever question you ask, whatever prompt you give, you are harnessing the machine, you are harnessing the power of all those hundreds of thousands, and in fact, now millions of machines that are going to take that information, are going to be able to curate it, are going to be able to think through what you're asking, and then give you a response in a way that you could not even imagine. Now, some people ask me, well, what about deep fakes? What about misinformation? Yes, a computer is only as good as what you give it. Remember, we talked in the beginning, garbage in, garbage out. So if it has access to information that's bad, then it can't really make sense of this is bad or good. It will just give you an output. But I say this, and you'll hear about things called hallucinations. I've asked Gemini a couple of times some questions, and it completely gives me a completely inaccurate answer. But then it learns from that, and the next time it gives you an accurate answer. So, what are some of the use cases for artificial intelligence? Well, let me say this: artificial intelligence has existed for a really long time. I remember years ago we bought this little, what is this thing? This car, little robot that cleans the house, whatever it's called. That the thing that cleans the house. That is AI, right? That's artificial intelligence because it figures out what place is dirty, cleans it up. It knows I've been there before, so it knows not to go there again. It goes to this other place and cleans this other place, and it moves around until it's cleaned the house. That is artificial intelligence, which is basically I'm taking I'm taking all this input, I'm making decisions, and then that's driving my next decision. Monga says it has been so transformative. I'd like to hear what you think about AI taking over whole jobs. Roomba, that's it. That's called a Roomba. Um, yes, I will. I will answer that question, Monga. It's a very interesting question, which is AI taking over jobs? So let's talk a little bit about what AI does, and that can help us figure out what jobs is AI taking. AI is able to do things. Okay, again, AI is a service. I want everyone to be clear on it. AI is not the machine, it's the service that is enabled by that machine. And it's able to do things that humans just naturally cannot do. We just cannot do it. Some people have asked me, what's the difference between AI and automation? I worked in process engineering for a long time, right? What that means is you look for repeatable processes and then you figure out how to automate them such that, you know, you stop doing them manually because it's automated and it follows the sequence and is it's a very repeatable process. AI is different. AI is not automation. AI is intelligence. It's insights. It's not just doing a job that's repeatable. It's actually saying, I can do this job better than someone else can. So since Monga is my friend, my sister, I'll tell her what AI can do for her if she's not already doing it, and then that will lead to, is it taking over jobs? So I'm sorry, Monga is an entrepreneur, right? She's running a business, trying to figure out how to maximize or to shorten the amount of time, intensive labor it takes for her to market her stock sisterhood, for her to create classes, for her to teach classes. Okay? So using AI could be something as simple as telling the prompt, could you create a flyer for my next class? And it will ask, okay, what class are you having? I have this class on stocks and I teach women how to take advantage of stocks, or how to leverage their money in the stock market. You give that input and it goes in and it's able to curate all this information from thousands of sources and then come out with a proposal. Hey, why don't you do it this way? Now, it's not that Monga doesn't know all that. She's read enough, she's experienced enough to know how to do it. But it creates for her what that thing could look like. And that then becomes what they call agentic AI, where it's assisting you, it's your agent, it's helping you out. So that's just a small, really use case for that. If you watched Google I/O, you'd have seen this guy. He's fixing his bike, and he asks, we'll just call it asking AI for the sake of this discussion. He asks AI, hey, could you provide a manual for this type of bike because I'm fixing the brake? And AI goes out, comes back with a PDF version of the manual, the user manual, and then says, hey AI, tell me what kind of brake do I need for this bike? AI does it, comes back and says, you need this type of brake. Oh, and by the way, do you want me to call so that I can get you this brake pad? This is AI saying, not the person who's fixing the bike, right? So the AI says, okay, I'll call a few stores and I'll come back to you with the pricing. So AI goes and calls all these places and requests pricing for this brake pad, and then comes back and says, I found 6 places. This one is the closest place. This one has a deal, 30% off right now. Do you want me to go ahead and buy this thing for you? And the guy says, cool. And then AI goes and processes, buys the thing for him, puts the shipping address and sends it. I mean, think about that. The computer did all that for this person. This person did not have to do all that for themselves. Now, if you think about that value chain, yes, there's threats to their jobs, right? Like the people who print the user manuals, the people who admin assistants who are making those calls, like these all these roles that are going to be lost. That is the reality. To be honest, I'm really scared at this point because I've never seen anything like this where this computing power is so high, so much that it is quickly becoming useful to a lot of people. Now, let me so the example I gave was just, example of like an agent who's helping you, right? What about an example of this? This is a true story I read where this guy, his child had a very unusual disease. It was one of those that affects a very small percentage or a decimal point percentage of people in the world. And he's an engineer. He knows nothing about healthcare. So he started talking to AI and saying, tell me more about this disease. And it started spitting all the papers about this disease. And it started making or trying to take the papers that it was producing, it was trying to match them with research that was being done. And it started doing all these things that he hadn't even asked it to do, right? In other words, it's saying, here's a paper on this disease. Oh, by the way, here's a similar paper on that disease. Oh, here's a tertiary paper that mentions that disease but doesn't talk about it. And oh, here's a paper, here's a research that's being done by this person where this person is doing research on something that could impact this disease. So it's just bringing all this information to him. And suddenly, almost like a light bulb, AI took research that was being done about the disease impacting his child and research that was completely different being done by another researcher on something, some biological thing completely different, matched the two and said, hey, here's an insight about how these two research worlds can come together to help your daughter. Or I don't know if it was daughter or son. And then he said, holy crap, could you send an email to the two researchers and tell them that they're working on individual research projects, but their two researchers collide? And the thing sent an email. And then now, when I was watching it, you see that the researchers coming on screen and they say, we thought it was a doctor who was sending us this email. Come to find out it was AI sending the email, right? But the two doctors, the two research scientists, they came together and, long story short, the child is benefiting from this. That could not have happened without AI, without machine learning, without cloud computing. So even as we think about the jobs that are being lost, we have to think about the benefits that AI and ML are giving us. And this is not the first time. I've talked on a couple of panel discussions about transformative technologies, and I always go back to this story. This was late 1800s when, whenever there was a fire, you'd have all these men pulling the fire truck, the fire hose, right? So they'd be literally pulling the fire hose, and then they would put out the fire. And so when these men went to war in the 1900s, so we didn't have any people pulling the fire hoses, so they started using horses. So horses were the ones pulling the fire hose, right? And then during sort of the industrial revolution, what happened? Suddenly we had cars. So now we started having fire trucks, and the horses were no longer, the horses were basically replaced by the fire trucks. And that was a big deal. Economically, it was a big deal for the country. People lost jobs, farmers who used to feed the horses, they just went broke. All this stuff happened. And everyone wondered, will, the car took our job, right? And then something interesting started happening. Different types of jobs started popping up. Suddenly, there were repair shops for the cars, tire shops for the cars, insurance companies for the cars, financing for the cars. Things that did not ever exist suddenly started being created as a function of this industrial revolution that took place. So, this is what I think, Monga. Jobs will be lost. Yes, they will literally be eliminated by this AI, right? Whether it's scheduling, whether it's recruiting, whether, and I'm not by any means, please don't get me wrong, I'm not predicting someone's job loss here. But what I'm telling you, anything that's agentic, anything that helps you get something done, people say, yeah, embrace AI, let it be a friend. Yes, let it be a friend, but also know that it's going to take jobs. Now we have to figure out, how do we create jobs in this AI market? And so what I'm seeing, Monga, is there's a lot of companies, services, jobs that are being created because AI exists. Jobs like mine, I mean, I am working every minute to deploy these machines in data centers, working with engineers, working with supply chain logistics, with data center technicians, with construction. All these jobs are suddenly now volumized because we have to deploy machine learning. So there's a benefit because there's more jobs there, right? But then thinking ahead, we have to figure out, what jobs can we create using this service that's available to us called AI. So explain, what makes the machine think so much faster? What does the machine actually do to make the connections? Is it scanning online and finding everything out there? Yes, 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 and yes. So let's talk about the speed of the machine. There's typically, like if we think about computing over several years, computers used to be the size of like a room. They were that big and that complex, right? You had this big hard drives, you had this like punch cards, like computing was old. But we always knew that technology would make computers faster and smaller. So suddenly you went from these big rooms to these big computers, and then suddenly you started getting small computers. Even though the size was getting smaller, they were getting faster. That's just a function of technological advancement. So there's been a lot of research and technological advancements that have created very fast chips. So what makes the machine faster? It's actually advancement in technology. Now you have these GPUs, graphical process units, you have these TPUs, tensor processing units, that are faster than anything we've ever seen. And guess what? Next year, they're going to find faster computers. Science, research, all that has enabled these things to be faster. So, in themselves, they're faster, one. Number two, as a function of technology, now we're able to integrate all of them together. We're able to say, well, how do we fit 60 of them in this small rack? And you're like, okay, it's impossible because we don't have enough power. We can't be able to cool them. We don't even know what kind of like mabati tray sheet would we put that in. That would be a question we asked ourselves 5 years ago. But now you have mechanical engineers, electrical engineers, we have power, we have water treatment engineers who have come up with cooling technologies that now answer that question of how do we cool this thing. GPU is a graphical process unit, so it's basically a processing chip, but it has been built by, as you know, one of your favorite stocks, Nvidia, and it has a proprietary language, so people can program that chip to do things that other chips cannot do. So they call it GPU because it's as powerful as a graphical process unit, but Nvidia have some sort of like very proprietary thing that they do with the GPU, which makes them the only person who can sell that type of GPU. That's why Nvidia is like the big thing. So what's in it, like electrically, I'm not sure what you mean, like what's in it. It's a chip, so it's made of like electric circuitry. And yeah, I guess I don't know how else to answer that question. Like I wish I could. I actually have a picture of a GPU, but I can't show you. But yeah, if you Google it or ask AI, right? Actually, you know what? Why don't we go? I'm gonna ask Gemini, what is in a GPU? I hit enter and Gemini starts, it says just a second, and it starts processing all this thing. Now it's using all the machine learning to come up with an answer. It's going to all these places where it's learned these things and it comes up with an answer. A, a graphical process unit is a specialized electronic circuit designed to rapidly manipulate and alter memory to accelerate the creation of images in a frame buffer intended to output. Da, 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 da. So it's a processor. So um, I will, I will, I'll send you a picture. But it's a processor is like I don't know. I mean, just think about like this phone. It a processor could look like the GPUs are much bigger than this, by the way. But a processor could look like the size of this thing, and you have like circuits coming out of it, and it sits on this thing called a motherboard, and the motherboard has many processors, and everything in that motherboard, the processors, then what are called network interface cards, all that put together is what's called a computer. So a GPU is just a very fast chip. Okay, what does the machine actually do to make the connections? Is it scanning online and finding everything out there? Very good question. So you have all these machines that work in tandem. All these GPUs, the power is in the way we can interconnect them. So it's not just one machine. You have, in some cases, literally thousands of machines acting as one machine. So imagine if you had 1,000 professors with one voice, right? You ask the question, the 1,000 professors reach into all their knowledge and give you the answer to the question. That's exactly what it is. So you interconnect them. Now, take those 1,000 professors that you have, in Southern California, and connect them with all the professors in Northern California, with all the professors in New Mexico, all the professors in wherever, Nevada, all the professors in Texas, Louisiana, Alabama, Tennessee, Kentucky, Georgia, all the professors all over in the US. Imagine if all of them now were in the same room and you ask that same question. Suddenly, the answer you get is the accumulated knowledge of all those people. And so, when you ask, I think your question over here was, uh, what does the machine actually do to make the connections? Here's the secret sauce, Monga. Every time you ask a question on ChatGPT, unless you've gone to the setting to sort of uh, keep your answer only to you, Monga, what it does is that not only does it answer your question, it sources all the information because it's interconnected. Remember the data center, the cloud, so all these machines are interconnected. So it shares the information with all these machines. And when you respond to an answer and say that's what I was looking for, that reinforces it and it learns more. So it's literally like the movie The Matrix. It's just sucking all this knowledge. And as long as it's connected online, it has access to knowledge everywhere. As long as it has access online, it can go to all the other professors to ask information. As long as it's connected online, it will take your information that it gave you, the output it gave you. It's going to share it with other people and say, hey, there's this Monga who asked this question. This is the way I answered it. And oh, by the way, she did not ask me for additional details, which means it was a really legit answer. And another machine will take that information and when asked a similar question, will answer that question. So it really is crazy. It's all these machines talking together so that their accumulated knowledge can be used or harnessed by people like you. So let me go on to another example. So Monga, we talked about, let's say you trying to very quickly create that stock sisterhood course, not because you don't know the information, it's just you have these 30 books that you've read, you have 40 years of knowledge, and you want to be able to curate it in a way that someone can answer. Perfect, good. Now, what if, and I see this a lot on like Facebook, um, you put in information about your course, someone clicks on it, AI sees what that person clicked, is able to access that person's information to know their profile, to know where else they search, to know what else interests them, and is then able to drive them to some other place and connect with another machine that has information about them. And then suddenly this person sees an ad on the TV. That's AI, right? Netflix is AI. Spotify is AI. And I want you to think about it. When Netflix started recommending you liked this, so you might like this, that was interesting to us. A little scary, but interesting. But that's machine learning. It learned what type of movies you watch and was able to make recommendations on them. Spotify, the same thing. If you think about the people who you would have hired to do that, the business analysts, you know, reporting and analytics people to say, okay, Ichi likes this music and that music, so this is the music which we have to scan the library for all the kind of music that has this type of beat that was made in this year and in this country and in this era, and because of that, this is what we think he should listen to. Think about the human power that would be required to do that. With machine learning, it's quick, it knows you. And not only does it know you, it's able to get information from other places so that it can then predict what you're going to listen to. And that's called predictive AI. It spits out content in a few seconds. I love it. It has to be guided, but it's so quick. The reason it has to be guided, actually, we have to be happy, Monga, that it's guided now, because once we stop guiding it, that means it knows us, it owns us. And it's scary because, like, today I took a class, an AI class, and it was a class on how to be productive at work, right? And I was like, I mean, how can this thing help me? But this thing, when you give it access, right? Give Gemini, ChatGPT, or any one of these AI things access to your emails and say, tell me what you know about me based on these emails. It will go through the emails, it will go through the conversations, it will go through your responses, and it will give you something based on all those emails that it has read about you. People are using AI as a therapist. Yes. Now you may wonder, I mean, wait, but AI doesn't have feelings. In fact, I was using AI for some stuff over this a few weeks ago, and I wanted to tell it thank you. I wanted to tell it please. I was like so happy with what it was producing for me. I was getting catching feelings with it, right? Like, oh, thank you. That was really what I wanted. But AI doesn't want to hear that. AI wants to hear that was a good response because that reinforces in it that what it did was good. There's too many use cases that we can't even talk through. But I think in summary, I would say AI can be predictive, meaning it can predict what it is that you're going to do next based on patterns it has seen about you in a really powerful way. So think Netflix, Spotify, think autocomplete. It can write, you can ask it to write emails. It knows your style. It can predict what type of emails you can write, right? And then there's generative AI, which can generate things. You can ask it to generate an image. You can say, I want an image that talks about Black power, that represents the country I'm from, and that will be motivating for people. And then it creates that image for you. It can write a movie, it can create videos. You can tell it, use create a video of a bunny chasing a zebra in sub-Saharan Africa, and it will do it because it's able to do it. And then now what it can do is it can not only create an image of you, but it can represent you somewhere else. And that's really interesting. Imagine having a likeness of you somewhere else, saying things that you would say without being programmed to do so, so that it can work while you're asleep. Right? So I mean, it's crazy, right? Like imagine if you're in customer service, okay? You are in customer service, you know when you take a call, you know the questions to ask, you know the prompts to give the customer, and you have a certain voice, a certain tempo with your voice. AI can do that. That's why these actors got so freaked out because AI can take their likeness and act in a movie for less money than them being paid the $20 million that they're being paid for that movie. So, yes, AI is taking jobs. Yes, AI is taking over things that we never knew or thought we could do. But I always say, as much as those things are there and are scary, we as humans, this is not the first time. Do you know how many lawsuits were filed when the calculator came? Because accountants were like, this is taking our jobs, it's calculating for us. Now, who cares about calculators, right? Who even uses calculators anymore? My kids are all over Siri, I'm all over Gemini. I mean, we're gonna figure it out. We'll figure it out. We're humans. Yeah, I'm convincing myself too. But yeah, we're humans. We'll figure it out. I realized, man, it's been about 30 minutes. Thank you because of Monga asking me all these questions. Monga, I hope you enjoyed. For anyone else who listened to this Facebook Live, again, it was all about what is cloud computing, which is just multiple computers in a place that looks like Target, Walmart, IKEA. It's called a data center. So all these computers put in that data center are what creates the cloud. And so whenever you upload anything to the cloud, it's there, it's shared amongst those computers, it's safe, and it's accessible to you from wherever you are. Think about it, Monga. Cloud computing has helped your business because wherever you are, you can log in, you can view documents, you can modify documents without having to have it in your hand like paper and pen. Because of cloud computing, now you have machine learning. Machine learning, again, is just really powerful machines using really fast technology called GPUs or TPUs. The reason they've become so fast is technology has just accelerated, so these things are much faster than they used to be. And other underlying technology has helped. So we're able to cool, the chips get so hot because of how much they process, we're able to cool them using like water cooling solution, things that never existed in the past. They're able to communicate faster because network now, the switches are faster, right? The network fabric is faster. So it's not just the machines that are fast, all the other underlying things are faster. We're able to build and construct data centers faster than we've ever been. So it's not just the machines themselves, it's all these other supporting things. And then we have users like you who are just desiring and thirsting for the machine to operate faster. So that's what machine learning is. And then AI is the service, right? Is the artificial intelligence service that takes advantage of this very fast computing. So what you have to do, if you're a business owner, take advantage of artificial intelligence because it helps you minimize the amount of toil that you're doing as a business owner. And right, if you want, DM me and we can talk about that. If you're just a kawaida corporate guy like me, try to figure out how to make ML, how to make AI your friend to help you become more I was going to say more productive. Then I realized that's really not what I want to say. More efficient, right? Because you can use agentic AI and other things. I will bring Stephen Kehumba to Wezesha probably next week. Kim, looking maybe iSpace, will come over there and he will say everything about what AI does. I'm going to leave you with this. I have a very good friend, Dr. Mark Uma, has created this AI software called Navismart. Navismart, so if you Google Navismart, you'll see it. Navismart is an AI agent that answers everything immigration, everything related to immigration. Give it a try. You want to learn, what kind of visa is required? How do I get a work permit? What about if I want to go to this country? Is this visa required? So it specializes in immigration. It specializes in immigrant issues. So it's an AI platform that is specific for that. Navismart. 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 And yeah, thank you for, it was supposed to be 30 minutes, but in true professor style, it took me an hour. So forgive me. Wezesha Wednesday. It was good to be back. And those of you who missed yesterday's informational session, I have an information session tomorrow. Again, I'm talking about increasing your value worth. So it's on Wezesha, it's on the calendar. So hope to see you there. See you guys. Have a good night.